So on Marius Hornberger's YouTube channel, the viewer has made a DXF file of the cam blocks and the cam levers. His plan specifies that you make the levers out of 6mm thick birch plywood and then the rest of the blocks out of 12mm birch plywood. So I only have 12mm on hand, so that's what I'm going to use for everything. I think it affects how low profile the blocks are. So I think at some point maybe I'll remake them with thinner plywood, but obviously with what's going on in the world today, I'm not going to the hardware store. So anyway, so I took this DXF drawing and brought it into Fusion 360. And so here we are. This is basically the DXF drawing. And then I imported it into my own sketch. And so I kept everything pretty much the same except this diameter of these circles. And so Marius is using metric copper pipe, and I'm in North America. And so I just changed it to this North American standard pipe for half-inch pipe. And so that's pretty much it. I kept everything the same, and then I extruded these parts up 12mm. And so that's basically what this is. And I was basically about to go back into CAM now. This is the manufacturer side, so it's where you make tool paths. And I've done a little setup where I set up this piece of stock, and that's this light green block, basically. And so if we go into there, we'll see that it's 17 by 14 inches wide, and this Z is actually 12mm converted into inches. So I have a big sheet of this. I don't know if I'll cut it beforehand, but nevertheless, this is the setup for the toolpath. And so I was basically about to add the 2D contour to cut things out. So let's do that. So I'm going to select the levers, and then it asks you to select a tool. And so I'm going to select a tool, and this is sort of your tool management window. And so I have created a library of the various bits that I own and put them in here. And so if we go in, the one we're going to be using for this is a 1/4 inch spiral down cut. And so in this dialog, you basically enter in all the data for your particular bit. And so, you know, you enter the dimensions, whether it's a flat end mill, how many flutes it has, things like that. And then important is the speeds and feeds. And so my bit didn't really come well documented. And so what I did was I went out to Amana Tool and I looked up one of their bits that's very similar. So they have a 2-flute solid carbide spiral plunge bit. And so mine's a 1/4 inch. So I'm just going to borrow their specs basically and hope that it's good enough. So we're going to be running at 18,000 RPM. And at a 1/4 inch, we're anywhere between 180 and 250 inches per minute. And the chip load is 0.005 to 0.007. And just a heads up that these specs expect you to do 1D, and so that means you're never cutting more than the width of the bit itself. And so if you do take a bigger bite, you have to reduce the chip load. So it's just something to be aware of. So back to Fusion here. One of the other things that I've done is I made this J-Kong motor because this is my spindle. And so I modeled the holder to match my spindle. So in Fusion, you can simulate a tool path, and so it's very useful to have it help you out so that you know if your holder ever collides with a piece of stock or a clamp or anything like that. So anyway, I've modeled that here, and so that's what I've specified the holder to be. So that's kind of useful. So basically, we'll be taking that, and just so you know that the speeds and feeds that get populated here come from the tool that you just selected. But if you go to the tool library manage, what has actually happened is what the tool has been copied from your library into the document itself. And so now if you modify these, that tool, bottom line is just good to know that you have a copy. So I can modify the speeds and feeds or certain aspects of the cutter just in this document, or I can do it globally. So it's good to know that that's there. So anyway, moving on. So we now have our contours selected. So I need to go to passes. And basically what I want to have is multiple depths, because I don't want to cut this all at once. I want to step down a little bit. And then I'm going to say that I'm looking for about 1/10 of an inch. And we'll see what that gives us. So I'm going to click OK. And then it calculates the path. And you can see it actually decided to start the cutting on this third lever, which is fine. I guess I don't care. But more importantly, we now have four step downs. And so what I also need, which I'll go back into that to adjust, is that I need some tabs. So basically I don't want the bit to cut this piece completely free of the stock, because it's going to rattle around in there and probably get damaged or tossed or whatever. So I want some tabs. So I want to select the tabs by points, and then I'm going to say 1 millimeter tab height. And then I will just select some points here. Probably going to overdo it a little bit since I don't really know how critical this is. So, all right, so that's pretty much that. So number of tabs. So now let's see what it updates that path to be. So good, you can see that it's leaving these little tabs basically. And so now if we animate or simulate this, you can either do it with the stock on or off. Let's do it with the on, and then you can see the path that it's going to take. It seems to leave a little notch there to go down, which is good. So I probably could be a lot more aggressive with this cut, but we'll see how this goes. It's cool. And those are the tabs that are left. So that looks pretty good to me. So let's zoom out. It'll go faster. All right, okay, so I'm pretty happy with that. So I won't bore you with the rest of it, but basically I'm going to go and make paths for everything else on here, and then I guess we'll go out to the machine and probably cut air for a good long time until we're satisfied, and then we'll let it loose and do the real cutting. After about 30 plus minutes tweaking, these are the paths that I came up with. So basically I split them into a couple different paths, and I'll probably run them separately just to take it slow. Things I had to take into consideration is I wanted to sort of bore the smaller holes first before I did the large contours, worrying mostly about putting pressure. You know, if I cut the perimeter first, then when I went to cut the hole, I might tear the larger piece free from its tabs, and so I wanted to cut these inners first, and so that's just something I did. So I'm kind of happy with the simulation, so I think I'm gonna basically turn these into G-code files and take them out to the machine. So here's the bit we'll be using today. It's a 1/2 inch solid carbide spiral bit down cut. We'll see how it goes. When I come into Mach 4 on the machine, the first thing I do is I enable the machine, and then I reference all home. And and I'm sort of hovering above my e-stop button just in case the machine doesn't stop. So you kind of have to know the limitations of your machine, and so in my particular case, my limit switches, my proximity sensors are my limit switches, and so they're also normally open switches, so it's slightly less safe. I could theoretically have a bad connection in there and don't know about it, and then when I approach my limit switches, they don't fire, and thus my machine won't stop. And so the good thing is that I've set up soft limits, and as you can see maybe here in the screen here, this dotted line box is essentially my soft limits of my machine. And so if I disable the machine and go to configure control in the homing soft limits, so I've set up basically some soft limits. I've enabled them by the check mark, and then you can see there's some figures in there that essentially set up this bounding box. And so that will now limit my machine. So from this point forward, I will never even get close to my limit switches as long as I've enabled them. So for example, here in the file ops or in the jogging, I have the soft limits on. And so that will prevent me from ever approaching those limit switches. So it's just an added layer of safety, and I've already encountered times where it saved me. So anyway, so now that we see that, so these are the work coordinates of the machine, and if we click on this machine coordinates, we'll see since we just homed, we're at the homing location. So the machine coordinates are 0, 0, 0. And the work coordinates are somewhere else. So anyway. So now we're going to enable and jog back over to then use our touch plate to find the corner of this workpiece. So I'm just jogging down. Good enough. So one of the things I always do is test my touch plate to make sure that it's working. And so it's working. Now I'm going to put it in place here. And then we are going to jog a little. And then we're going to find the corner of that workpiece, basically. All right, and so once I click OK, you'll see the work coordinates change from what they are now to what these. And so that has essentially changed the work coordinates of the machine. So here are the machine coordinates and the work coordinates. And so it's basically your two reference points. All right, and so now we know where the corner of that piece is. We don't need this anymore. The next thing we're going to do is to open the G-code file. And so these are the levers we just created. And so what I'm going to do is come here to the feed rate. There's this feed rate section, which is G01, and then this is G02. So this controls how fast the machine is going to run when you cut and when you're not cutting. And so I'm going to drive these down to 0 so I can sort of cut air and control things really well. And then I'm going to go to View, Fixture Offsets. And then for Z, I'm going to add 1 inch. And so this means that we're going to add this work shift so that every piece of G code that comes in interpreted here, this instance is going to add 1 inch to it in the Z direction. And so that's going to basically let us cut air. And so here you can see in the G code that we come down, and then here we're turning on the spindle. And I'm going to quickly turn off the spindle so that we just using this dial up over here so that we don't have to deal with that. So now that these are both 0, I'm going to hit cycle start. So here we go. I'm shutting off the spindle really quick. So it's really important when you're testing these for these to be 0, because the only reason nothing is happening is because these are 0. And so here I'm going to hit the plus, and so we're going to add a little rapid speed. We're not going to go full speed, but it'll just start moving. And so since the feed rate is 0, when this rapid is done, it's just going to stop. And so it stopped. Now it's important for me to take this back to 0 because I'm really trying to step through this slowly. And you can see where the G code is. It sort of scrolls down. So we're going to allow the feed rate to go up. And then you can see the bits. So we're basically like 18% of the actual speed that's happening. And so over in this window, these red crosshairs are telling you where the bit is in the toolpath. So obviously you can hear it makes quite interesting sounds when it goes slow. And so I'm feeling pretty confident about that, so I'm going to just pump this up a little bit more. Cool. And so we've come to the end of that feed rate, and now it wants to do a rapid. So I'm going to take this to 0 and then go up on the rapid. Okay. And so it basically retracted again and then went down. So that was somewhat unexpected by me. Alright, so that feed is done. So let's do the rapid again. So I'm pretty sure in the configuration of Infusion you could tell it not to do this retraction, and so maybe that's for future. So basically that's 100% speed right there, so that'll be interesting to see. So let's do one more round. There you can see it's doing those tabs. Now it's moving on to the next one. You can see we're over in the second lever now. So anyway, I'm not going to bore you with going through this, but that's basically the process that I've been using. So I cut air for a while until I'm confident, and then we do it for real. All right, well, that's pretty much it. I think other than maybe the failure of these tabs in a couple different places, it's not too bad. I also seem to nick into my Spoilboard a little bit. So at this point I still haven't surfaced it, so I guess I get what I get. So anyway, not too bad. Thanks for watching.